What's up, Dog Squad? And today I would like to introduce a new branch of this channel, and that would be math. Alright? So, to start off with our very first problem in this portion, we have the integral from 0 to pi over 2 of cosine x times sine x dx. Now, first glance, we can use integration of parts. But how I did it is I said, oh, let's look back to trig. We know that sine of 2x is equal to 2 cosine x sine x. Alright? So, using this, well, this looks similar to this, right? So what I did is I say, let's multiply both sides by half. So we have half sine of 2x equals a half of 2 times the cosine of x times sine of x. Now these will cancel out, giving us that 1/2 sine of x, sine of 2x, excuse me, is equal to cosine x sine x. Now we have two similar things. So what we can say is this equals to the integral from 0 to pi over 2 of 1/2 sine 2x dx. Alright, now since 1/2 is a constant, we can pull it out of the integral, giving us 1/2 times the integral from 0 to pi over 2 is of sine 2x. Excuse me. Alright, so now I said let u equal to 2x. Alright. Oh, I forgot the dx over here, sorry. So now, what does that mean for dx? Well, you say, oh, let's take the derivative of both sides. So we get du is equal to dx. Wait, no, sorry. We get du is equal to 2 dx, of course. Now, there's one problem with this, because this is solving for du, not dx. So now we have to divide 2 by both sides, so we get dx is equal to du over 2. So that's what we're gonna plug in right here, not this. So if we plug that in, we get 1/2 the integral from 0 to pi over 2 of sine u multiplied by du over 2. Now, there's a 1/2 in here. There's a 1/2 right here. So, I mean, that's constant, so we can just pull that out over here, giving us 1/4 times the integral of 0 to pi over 2 of sine u du. Now, this just looks like a simple integral, because if we look at our sines, we get sine. The derivative of a sine is cosine. The derivative of a cosine is negative sine. The derivative of a negative sine is negative cosine. And the derivative of a negative cosine is sine. So it's a whole loop back. So it's an infinite loop. Now, for integration, we know it's the inverse of taking the derivative, so we're going to go backwards. So we have the integral of sine will actually be negative cosine. So we have 1/4 times negative cosine of u, but we said u is 2x, so we plug that in. 2x evaluated to 0 of pi over 2 pi over 2. Alright, so I prefer simplifying this, make it look a little bit simpler, but all you have to do is distribute this 1/4. So we get negative 1/4 cosine 2x evaluated at 0 and pi over 2. So what this means is we're really taking negative 1/4 cosine 2 times pi over 2 minus cosine of 2 times 0. Oh, forgot the 1/4 right there. Alright, so if we look at our cosine graph, it looks a little bit like this. This is 0, this is pi over 2, this is pi, and so on and so on, alright? So this 2 times pi over 2 is just pi, since you can cancel out the 2's. But looking at this graph, we see that cosine of pi is negative 1. So this whole thing here will be negative 1. Multiplying that by the negative 1/4 we have is positive 1/4. Alright, and we want to add, because these two negatives turn into a positive, we want to add 1/4 cosine of 2 times 0 is 0. So cosine of 0 is 1. So this is just 1, so this cancels out because you're multiplying by 1. So you just get 1/4 plus 1/4, which is 2/4 or 1/2. Alright. So in simpler terms, the area of the curve given by this function, cosine x times sine x, the area from 0 to pi over 2 is exactly 1/2. So to recap, I just started off with a simple trig identity. Then I simplified from there. So yeah, this is the answer. Let me know in the comments how you solved it. Alright? Well, I hope you enjoyed the video. See you in the next video. Dog Squad out.